Hello and welcome back to Dr. Logic Awkwardly Does Logic, now with extra awkwardness because my new version of Zoom keeps messing up recording the whiteboard. Anyway, in my previous video, I know I told you that we would be talking about the rules of replacement, but I actually forgot one of the rules I needed to teach you first, one of the kind of derived rules that's just a derived rule. It's not one of the rules of replacement. And it's the rule of the transitivity of conditionals. And it's very easy and easy to forget. So let me bring up the whiteboard. I think the thing that I need to do is make the whiteboard full screen and then everything should work. So this is just a moment, I've got something on my writing tablet. There we go. Transitivity of arrow. Now, we will just call it trans, even though there are going to be other types of transitivity rules that we'll see, such as transitivity of identity. But, context will make it clear which one you're using, so you don't need to worry about that. And it basically says, suppose that you've got a proof. In some line I, you've got some conditional, phi implies psi, some sort of annotation, you don't necessarily know what. Later on, you've got another proof, another line of your proof, and it's a conditional that says that psi implies gamma. Again, you've got some sort of annotation, don't necessarily know what, doesn't really matter. Well, then at line n, you can write down a conditional that has the antecedent of the first one and the consequence of the second one, and just completely ignores this linking psi in between. So that is transitivity lines I and J. So there you have the schematic version of the rule. Let me write it out so you've also got the written rule. So if in a proof you have a conditional, phi implies psi on line I, and another conditional that has as its antecedent the consequence of the first one. So psi implies gamma, and this is going to be on line J, where our usual notes, lines I and J cannot be the same. I needs to occur before line N. J needs to occur before line N. It doesn't matter whether I or J comes first. You could have the second conditional before the other one. Order like that doesn't matter here. But if you've got this, then on line N, you can write a new conditional that has the antecedent of the first one as the antecedent and the consequence of the second one as the consequence. And this is with justification or annotation, transitivity, lines I and J. Now, as with any of the other derived rules, all that this one does is it simplifies proofs that we could have done without using this rule. And in fact, it's quite easy to show this. So suppose that we've got something where we've got the conditional phi implies psi on line I, and at line J, we have psi implies gamma. Sorry, that's not gamma, that's gamma. It's very easy to then derive the conditional phi implies gamma just using the conditional introduction rule. So that one says, say here at line K, I'm going to assume phi, and I want to try to derive gamma. Well, at line K plus 1, I can get psi through conditional elimination of lines I and K, because here we have a conditional phi implies psi, here we have the antecedent phi, so I can write down the consequence psi. Then at the next line, this is the antecedent of the conditional at line J. So through conditional elimination again, citing lines J and K plus 1, I can write down gamma. But then what this little subproof says is that if from the assumption of phi you can prove gamma, well, I can close that subproof and write down the conditional phi implies gamma through conditional introduction, lines K to K plus 2. So all that transitivity of the conditional is doing is getting rid of these three lines. Makes your proof shorter, makes them a little bit cleaner. You don't have to worry about keeping your scope lines all embedded and everything. So there you have it. This rule is a particularly interesting rule because it's one of the ones that has been around in logic for a very long time. In the syllogistic, it basically just is Barbara. So you can see that Barbara has this sort of transitivity notion in that, essentially psi here is playing the role that the middle term does in a syllogism. But even looking at propositional logic, you can find 13th and 14th century authors who are writing about rules of inference, rules of logic, and they have this rule. They don't call it transitivity. They just say that if, oh, can I say it off the top of my head? Whatever follows from, whatever is antecedent to the antecedent is antecedent to the consequent, and whatever's consequent to the consequent is consequent to the antecedent. So write those down, kind of figure out exactly what those are saying, and you'll see that it's just two different ways of specifying transitivity. And there you have it. I sure hope that my recording of the whiteboard worked better this time. Next time, we'll actually get into talking about the rules of replacement. So see you then. Cheers.